Try it. Okay. We should be live. Seems a little latent. Curious if the audio is as latent as the camera. Let me just double check something with the camera settings really quick. Show me the camera. Okay, let's see. How do we want to do this? We go here, we go here, we change this, we go up to, and then we go up to Zygos. And just a heads up, still sorting out a couple things. Yeah, my shutter speed is way too wrong. Why? Yeah, it's too slow. Interesting. Fixing a couple more technical things. How is this? Is this way too dark? That's very, very dark. Let's crank up the ISO. Feels better shutter speed wise, but it's still very dark. But if it gets too bright, it's going to be grainy. Oh well, I think that's fine. Okay, cool. Headphones, good to go. Pull up Cider really quick. Hopefully I don't have to sign in. I don't know if Cider's going to launch. All right, Claude, let's resume where we left off. Perfect. Okay. Give me, oh, there we go. I was like, where is Cider? Please pop up. Yeah, this is good. We'll do this. Plain clear. That's not headphones. Let's try this. Connect. Cool. Okay. We're live. Is there anything? There's one last thing I need to do. Which is grab this, paste this in Discord. Close this. Give me 1 second. My recording device is being very, very slow. And then we'll get started in just a minute. Okay. Yeah, there's like some weird camera latency, and I don't know where it's coming from. But we'll manage. We'll manage the camera latency. One last thing that I need to do, which is pull this up in a new tab. Try this again. Go up here, pop out the chat. There's probably a way to actually like do all this before I start streaming, but it is what it is. Let me check one more thing and just make sure there's no like camera effects that are on that are affecting the um, performance of the camera. It does not look like it. Okay, we'll run with it. My camera might be slightly behind my actual audio, but it is what it is. Yeah, it's a little behind. There's like 1 second of latency, but oh well, we'll manage. You're not here for my face, anyways. Okay. Yeah, so ZigOS. So this is a continuation stream from 2 weeks ago. I was going to do one last week, and we just did not have the time. Um, so before I get started, one small bit of housekeeping. There is a storm that is coming in where I live. So we'll stream while we can, probably for a couple hours at least. But there's always a chance I lose power because I live out in the country, and that tends to happen. Okay, cool. So this is, if you're just joining for the first time, I'll just do a quick walkthrough of what we've built so far. It's really small. Um, I think there are two really important things that are worth mentioning. So the very first thing is we were using limine. I still don't know how to pronounce it. It's Limine. Um, and it is taking care of like our bootloader type stuff and making sure that we don't have to do the jump from 16 to 32 to 64-bit. All sorts of really nice things on our behalf. My plan is eventually just like move away from that and do those pieces myself. But while I'm just building this initial like foundation, I figured I would just leverage the tools that are available there. Which means we run into an interesting scenario where we get this. If this QEMU boots up properly. Oh, it did boot up properly. Sorry, we're already in. It's working as expected. So you might be wondering, well, it's not doing anything, right? Worth mentioning, we're not doing like a full Windows style operating system. This is just minimal for research purposes, learning more than anything else. But that's what we're working on today. So also, if you're just joining, the plan is to prompt Claude for questions and give it some snippets and give it access to our code base so it can help guide me in the appropriate path forward for learning and building this stuff. I tried using the OS Dev Wiki in the past. I found it kind of difficult to reason with. And then also the mental overhead of translating all the C examples to Zig was a bit of a pain. So my thought process here is I just use Claude to unblock me and to ask it questions with the effort to learn more. Everything I've done on stream previously, except for one thing, because I could not sleep while I was thinking about this. Where we left off in our last stream, we had an issue where we were in a crash loop, and the fix for that is actually really straightforward. So I shared some of the issues that we had that we were running into, and the answer is essentially we needed to add the ability to. I'm trying to find the example here. We needed to be able to write out to QEMU so we could actually debug the issue. So we ended up adding some. Let's see. This right here. So the serial write piece. So we could take a look at this too, and we'll look through our files before we get started. But essentially, what we were doing was just making sure that everything is working like we would expect it to, and then we added the serial write. So we're writing out to a very specific port using assembly. And you can see here we're doing serial write A, R for revision, B for the next step in the process, C, D, etc. We were breaking right here because we were trying to do VGA rendering. In our actual steps that we have planned out for us, getting the limini frame buffer is next. So actually, it might not be next, but it's soon, if not next. So what I ended up doing was just commenting this out for now, and we can take a look at that too. So if we look at our, let me try again. Source. Oh, I typed Vims, not Vim. My bad. Yeah, so we commented this out, right? So our original plan was to write ZigOS to the VGA text mode memory. but that was causing issues, and I think we just have a little bit more work there. So I wanted to make sure that we were actually getting output and doing our serial writes and everything was working like we would expect it to. So yeah, that's where we're at. Um, we have some limonene stuff up here at the top. Keep in mind that we're kind of limited on what we can leverage for our standard library here, since we are essentially the operating system. We can't depend on the operating system. Custom panic handler that just raises a halt command through assembly. What else? Actually, to be completely honest, there's not a ton going on in our main.zig. We have an assembly file that handles flushing here for our GDT. Our global, I've already forgotten what GDT stands for. We had answered that question previously. It's data table, right? Global data table, GDT. Yeah, I think so. Global descriptor table. That's right. Global descriptor table. So yeah, we had a custom assembly function that we wrote here to take care of that. What else do we have? GDT.zig. So here's actually all of that GDT type stuff. We're using pack structs up here. So we have our entries, pretty heavily commented. Our GDT descriptor here, GDT entry, and then that flush right here, which is calling that GDT flush that we have. Anything else worth mentioning? Source build.zig maybe. Oh, sorry, that's not in source. It's just build.zig. Yeah, so targets, specific targets, x86, 64, freestanding, and then our ABI is none. And then our root module here, we do have our red zone disabled. Our code model is set to kernel. Yeah, I think that's where we're at for now. We have this build ISO script. This is a shell script. To be completely honest, Claude did write all of this, but that was also on the last video. I don't want to spend time working on shell stuff if I can avoid it. So the goal is focus on Zig, and Claude took care of stringing together these commands for me, and I am appreciative of that. Linker. Here's our linker. Not a ton going on here. Placing things at the 1 meg mark to start. Some alignment for our text region, our read-only data, general data. Everything's aligned as well. But yeah, that's where we're at. So the plan is let's move forward. So we're back in our Claude session. I kind of have already forgotten where we're at. So I'm just going to ask, I'll say, okay, this is working. So what's next? $20 in extra usage on us. That seems like a trap. Seems like something they let you burn through really quick, and then you get used to extra usage. All right. Yeah, I think that's the gist of the files that we have here. I do think it's worth mentioning that limonene is taking care of a lot of stuff for us. And again, this limonene bootloader, limine. I have no idea how to pronounce it, but yeah, this bootloader. Okay. All right. What's the plan? What's the plan? Before moving on, commit everything you have now. That was a lot of hard-won ground. I think we've already done that. Let me just double check, but I'm pretty sure we have. Yeah, we have. Okay, next is IDT and exception handlers. The goal is to teach the CPU what to do when something goes wrong. Right now, any exception, such as divide by zero, page fault, anything, causes a triple fault and a silent crash. After this task, exceptions will be caught and we'll be able to see what happens. That sounds really useful. Concepts. So, what is an interrupt? An interrupt is the CPU pausing what it's doing to handle an event. There are two kinds: hardware interrupts, like a device, keyboard, timer, um, disk, signaling the CPU that something needs attention. And then there's exceptions. The CPU itself signals that something went wrong, like division by zero, accessing unmapped memory, illegal instructions, etc. Both are handled the same way. The CPU looks up a handler in the IDT. What is the IDT? The interrupt descriptor table is a table of up to 256 entries, one per interrupt slash exception vector. Each entry points to a handler function. The CPU finds the IDT via the IDTR register. My guess is IDTR is register, so this is a nice little ATM machine type dilemma. Loaded with lid T, exactly like LGDT for the GDT. Oh man, okay. The first 32 vectors are reserved for CPU exceptions, so divide error, invalid opcode, double fault, general protection, page fault. Okay. Why do we need assembly stubs? When the CPU exception fires, the CPU pushes state onto the stack before calling your handler. SS, only for privilege change. RSP, only for privilege changed. R flag, CS, RIP, error code. Okay, cool. The problem: some exceptions push an error code and others don't. If you call a uniform ZIG handler directly, you can't tell which is which. The standard solution is a small assembly stub per vector that normalizes the stack, such as pushing a fake zero error code for exceptions that don't push one, then calls a shared ZIG handler. Okay, interesting. I think this makes sense to me. I think I understand why we would do that. What is the calling convention at exception time? The CPU uses no calling convention at all. It just pushes registers and jumps. Your stub must manually save all general purpose registers, push add equivalent in 64-bit, call the handler, and then restore them, and IREQ interrupt return. So the plan, you'll create these files: so source IDT zig, okay, IDT stubs, update source main to call IDT init, update build.zig to include IDT stubs. For now, we'll handle 32 CPU exception vectors only. Hardware interrupts can come later. Okay. So we have our IDT. So let's go ahead and create this. So we'll just touch source IDT.zig. I guess we could just vim that actually. So an IDT gate descriptor is 16 bytes in 64-bit mode. Okay, sure. Const IDT entry. It's going to be a packed struct. This is actually really similar to the GDT table or the GDRT table. I don't remember the exact name. Bits 15.0 of handler address. I'm going to turn my music up too. It's a throwback to some of my favorite songs from a long time ago, so it's hard to not jam out to them. Code segment selector 08, our kernel CS. Okay. And give me 1 second while I move just a couple more things. Okay. Just trying to get my keyboard closer so I can be in this for longer without my shoulders hurting. Interrupt stack table offset. 0 is equal to use current stack. Oh, also, while we're typing this out, one thing that I think is important, Claude is guiding us. This is an experiment in both me learning to build an operating system, but also an experiment in seeing how well these tools are at guiding people through somewhat unknown territory. Operating system development's not, completely unknown at this point. There's quite a few people who have done things in this space, and Zig is not completely unknown to these LLMs yet either. There's people who have done stuff in this space. So the goal here is to siphon the learnings from the data that the LLM has been trained on and convert it into something that I care more about, which is Zig instead of something like C. So we have a reserved, which must be 0. Interesting. Come on, don't do this to me. Okay. The flags byte for a kernel interrupt gate 0B1. Yeah, ones and zeros binary. Okay. Bit 7 present. Bit 6 to 5 DPL 00. So ring 0. Bit 4 storage, bits 3 to 0 gate type. So in our case, a 64-bit interrupt gate. An interrupt gate automatically clears the IF flag, disables interrupts, while the handler runs, preventing nested interrupts from causing chaos while you're handling one. Makes sense. Okay, so let's go ahead and make our IDT descriptor, which is going to be a packed struct, size U16, offset U64. Make our table here. So IDT entry. Whoa, type that wrong. My bad. 32. And I just realized this text is tiny. I wish someone would have said something. My apologies. I am so sorry about that. Let's try this again now that we have slightly larger text. We'll make this one even bigger. Okay, so we have our IDT entry list. It's 32 units long, standard mem zeros. Is that a thing? I've not used that before. Super John Soto. Hi, I'm doing pretty well. How are you doing? Is this a thing? It is a thing. Generally, Zig users are encouraged to explicitly initialize all fields of a something struct explicitly rather than using this function. However, it is recognized that there are sometimes use cases for initializing all fields to a 0 value. For example, when interfacing with a C API where this practice is more common and relied upon. Okay, cool. Makes sense. So we have our IDR. Sorry, this is not IDR, this is IDT. Okay. This is called from IDT stubs.s, the common handler for all exceptions. We'll export function exception handler, have a frame. It's going to be an interrupt frame. We don't have that defined yet, do we? Okay. Yeah, that's what I was curious about. Okay. For now, print the vector number to serial and halt. We'll make this more sophisticated later. Makes sense. Make sure our frame is not recognized as unused, and then while true, do an assembly volatile halt. Sounds good to me. A function called set entry. It's going to take in a vector, which is a U8 here, and then a handler, which is going to be a U64. Return void, and then we're just going to go ahead and set that value in the vector to IDT entry offset low truncate handler selector. Just as like an important tidbit, just kind of to dog on LLMs a little bit here. Truncate, I don't think is a thing. I'm pretty sure it's trunk. So, well, I don't know. Let's find out. Is there a truncate? There is a truncate. What's the difference? Okay, to dog on me for a little bit, I was getting a little aggressive with the LM there, and it should be truncate, not trunk. I will happily admit when I'm wrong, and that was a time where I'm wrong. All right, our flags. This was defined earlier. We talked about those just a few moments ago. Offset high. Sorry, let's do mid first. Truncate handler bit shift over by 16. Offset high equals truncate handler bit shift by 32. Reserved, set that to 0 because that's what it needs to be set to. You got it. That's our set entry. We do need an init function to initialize our table here, so we will work on that as well. Stub 0, stub 1, etc. are defined in idt stubs.s. We'll declare them extern and set each entry shown in full in step 2. I don't know how valuable that comment is, but we'll remove that one. IDTR, we're going to set an IDT descriptor. Size is going to be at size of, type of, this one, IDT, -1. And then our offset, int from pointer. I don't think that's going to be that easy, but we'll try it out. All right, what else do we got down here? We have our assembly. Yeah, okay. So ASM volatile lid t percent IDTR. I am very curious if this is going to work like we would expect. And the reason I say that is because I feel like we had several issues doing our inline assembly when we were getting into our GDTR. Int from pointer IDTR. And then memory. We'll try it. We'll see how it goes. Okay. You'll notice lid T has the same inline assembly problem as LGDT. We'll solve it the same way, a single LIDT and IDT stubs. Okay, cool. Yeah, sounds good. Interrupt frame. This is the CPU state the handler receives. Wow, okay. Pub const interrupt frame. It's an external struct saved by our stub R15. Man, I'm going to be honest. Part of the requirements is that I can't copy anything in, so I need to actually go slow and think about everything, but that is looking like something I'd love to copy and paste. Okay, so we have an external struct saved by our stub in reverse push order. R15 is a U64. R14 is a U64. Doesn't mean we can't NeoVim our way through this, right? Let's just go down to R8, and then we get to our RBP. Okay, so R11, R10, R9, just straight 9, okay. R8, those are all 64s. RBP, RDI, what comes after RDI? RSI, okay. Whoa. 1, 2, 3, 4. So after RSI, we have RDX, which is going to be a U64, RCX, RBX, RAX, pushed by the stub or CPU. I think we're going to end up asking Claude questions about this struct here in just a second, because to be honest, I don't know what most of these are. I'm assuming R is register, but a little more information would be appreciated. Okay, pushed by the stub or CPU vector, it's going to be a U64. Error code is also a U64. Pushed by the CPU automatically. RIP U64. CS is a U64. RFlags is a U64. RSP is a U64. SS, you got it, U64. Okay. This is the tricky part. You need one stub per vector. Man, I hate writing assembly. Geez, this is a long one. All right, cool. Let's do it. Actually, if we're going to be writing assembly, I need more peaceful music. Let me see what else we got. This is a very small playlist, but I really like this song, so let's do that. Okay. What's the file? Source idt stubs.s. Let's do it. Extern exception handler. Do we have any extra languages for assembly? Not that I'm aware of. Okay, cool. Well, let's just do it. Macro for exceptions without an error code. CPU doesn't push one. Macro is our no error vector global stub / vector. Also worth mentioning, if anyone is tuned in and I'm sorry, 64 views, is that concurrent? No, okay. I was like, wow, that is way higher than I was expecting for how little the chat rate is. No pressure, by the way, just a random observation. Assembly, right? So let's talk about assembly. I don't know assembly very well. So if I do something that seems really off, please call me out. I would love your help. Push Q. This is a fake error code for uniformity. Push Q vector. Also, again, I feel like my font is just a little small. So if it is small, let me know and I'll make it bigger if need be. Okay, so we're push queuing a vector, which is the which vector fired. Hello, CIPW. Luna, out of the trash. Why are you being like that? Come here. Oh, people want to see you. Yeah, this is my dog Luna. Can you look this way? No, don't look at me. Look at the camera. Look at the camera. You don't want to look at the camera? All right. I'll put you down. Oh. Stay out of the trash. She is being a little pain right now by trying to dig through the trash for some reason. What app am I using for the music? I'm using an app called Cider. It's a Apple Music alternative for non-Apple platforms. So Windows and Linux in my case. My wife and I are both iOS users. We pay for the Apple family subscription, and for better or worse, use Apple Music. So I'd like to be able to use that now that I'm no longer on a MacBook. And I found, to be honest, I actually think I like Cider better than the Apple Music app on my MacBook. But yeah, it's called Cider. It looks like this. These are, playlists and stuff. It's all synced, so it's got all of my stuff from Apple Music and all the songs and stuff. So yeah, it's not bad. Okay, cool. So let's do our macro for exceptions with an error code where the CPU pushes one automatically. So we have a macro is our error vector. We have a global stub vector. And then we have the definition. Push Q. Yep, that makes sense. We'll push that vector. CPU already pushed the error code. Let's clean that up really quick. And we want to jump to ISR common end M. You got it. End our macro. I'm going to copy and paste. Sorry, these are constant definitions and then basically just a little bit of register pushing. We'll review what we have. And also, my apologies for the flashbang. I did not think that through. Okay. Am I crazy? Are these way... Yeah, they're all... what am I accomplishing today? Whatever's next on the list. So right now we're going through and I am trying to accomplish... That's a great question. What am I accomplishing today? The goal is progress. So I am ideally writing to a buffer and being able to visualize that buffer in QEMU would be a wonderful spot to at least get to today. Will that happen? I don't know. We'll see. When we start getting into the assembly stuff, I ran into some issues on our previous live stream, so we'll see if that ends up causing me issues again. I feel like I should macro this, but we're already halfway through sunk cost fallacy. Let's just continue. Oh, what did I do there? Weird. So yeah, I don't necessarily know what my end goal is for the day, but I would love it if we were in a spot where we could actually write out to QEMU at this point. I think that would be a very successful first step. Right now we have our program running in QEMU, our operating system, I guess, if you will, via... is it the end? Did I miss something? No, yeah, that is the end. Okay, cool. It's running. I can show you that in just a second if you'd like, but global libt load libt RDI, yep, and then return. Man, I do not like assembly. Okay, yeah, sorry. So what are we accomplishing today? Nice, we all tried. Did you see that a 15-year-old made an OS from scratch with a basic window manager? No, but I'm always ready to be humbled by 15-year-olds, so I believe it. I'm kind of curious to learn more. 15-year-old makes operating system. I'll make this bigger so I'm not the only one able to read it. Yeah, you have any more information? I'd be curious. Oh, on YouTube. On YouTube. They have a video I saw. Sure, I don't know if you know this, but I too use YouTube and I'd be happy to take a look. Do you know operating system? What am I searching? 15-year-old? Feels weird. Oh yeah, this one. I built an operating system from scratch at 15. Are you Misty01 or affiliated with Misty01? Are you trying to make this so it's something that you trying to get them views because it's working? That's really cool. I will have to check that out. I'm not going to watch it on stream. That feels weird, and I honestly don't know about the copyright of doing that. But I will gladly check that out at some point. And yeah, nice and humbled. Okay, cool. Yeah, I would love to get to that point for like a hobby project. To be completely honest, I am getting older, as people do, but I'm also just getting more burnt out, and I'm not sure if some of that is due to age or if that is due to like the recent trends in our industry or both. It could be both. Um, and I'm trying to find fun projects again that just get me excited about programming and building an operating system. Um, is yeah, it just seems like something fun to do. So they built their own bootloader as well. Same. I am Unc status. I don't know what Unc means. I'm old. We we just went over that. Is it uncouthed? Is that what it's short for? Is it uncle? Uncool? I don't know. I've got a million questions. I'm just not hip. Okay, let's step 3. So let's update our build.zig. Add the stubs. You got it. So kernel dot add nice typo there. Add assembly file b.path, and then we want it's in source idt stubs. Nice little assembly file for our unc as in uncle. Oh, okay, cool. Is that like a thing kids say, or is that just like, are you actually an uncle? What does that mean? I'm so out of it, man. I used to say all sorts of stuff that if I look back on it now, I'd be like, what in the world is that kid saying? But I'm just not at that point anymore. Okay, while you're explaining your actual uncle status to me, yeah, it's a thing going, people say. Okay. Oh, young people say. Weird. I'm sure older people said that I was actually, I'm positive older people said that I was weird when I was younger. I was very much a screamo kid. But yeah, I definitely feel like the current generation, I just don't understand. Gen Z, I guess. When is Gen Z? Gen Z. Tell me more. People born between 97 and 2012. Jeez. Yeah, I am a millennial. Is that right? I am. I'm a millennial. Yeah. The largest, most diverse, and highly educated adult population in the workforce. That's right. Don't forget it. Characterized by technology influence, delayed life milestones due to financial factors like student debt. Amen. and a strong preference for workplace flexibility and purposeful work. Much to my chagrin sometimes. Anyways, enough being unk and talking about how I'm old. Okay, cool. So we're importing this. We need to use it in our kernel main. So we have our GDT in it. After we initialize our global descriptor table, we're also going to initialize the IDT, which is interrupt descriptor table. And it's important for me to write these out so I actually remember what they are. IDT init, serial write, I. So we're writing out that the IDT has successfully loaded. That's what this I is for. And once the IDT is loaded, deliberately trigger an exception to verify the handler catches it instead of triple faulting. This is temporarily, add this temporarily after init IDT. Sure. Give me a U64, set it equal to 0. Prevent optimization. Interesting. I feel like this is not something you'd ever do. ASM volatile. Divide by 0. Bop, bop. 0. R. X. Pointless discard of local variable. Try this. Hey man, if this turns into an OS from scratch series, that would be exciting. Like how Cherno does their game engine and C++ series. I'm not sure who that is, but I'll have to check that out. Yeah, I don't know if I will do an OS from scratch series. So the plan is we're using Limonine or however it's pronounced to handle a lot of this stuff to just get me going. But once I get things like running successfully and into a state that I'm happy with, the plan is to peel back the Limonene layer and build that myself as well. So I guess in theory, like if I throw this on a playlist, you could watch the live streams from scratch. I just have to imagine, especially since it's a live stream and not me like really planning and recording, and I'm having conversations like this, which I would not do in a normal video. They probably will be really, really long. Like it would take a very, very long time to get through the whole thing. Not saying people wouldn't, or it's not worth the time, but just something that makes me kind of question it. Okay. If you add a serial write to exception handler before the halt, you'll see confirmation that it was called. Okay, so if the IDT works, this exception fires, your handler runs. Currently, it just halts. Let's do that. Let's add. Where is serial write defined? Search grep serial write in our main. Okay, yeah, that's fine for now. Okay, cool. So in theory, we should be able to build ISO and then run our QEMU. Okay, that maybe wasn't what I was expecting. Let me remove the no reboot and just see. Okay, we are definitely straight up booting over and over again. So question, with no reboot, should it crash? Like it's totally crashing. It appears to be crashing. I thought with no reboot, it would, sorry, let's be specific. QEMU would stay up. How do I debug this? Fantastic question, because I don't know. Wrong thing. Sorry. Give me metal. Where can I find metal? We'll start here. Cool. I have not had to do this yet, so we're going to attach GDB to. Interesting. All right, I'm down to give it a shot. Let's give it a go. So I will copy and paste this command. Okay. I wish I could make this bigger, like the QEMU text, but I do not see a way to do that. Yeah, we'll have to just manage with what we got. Crack open another tab. We'll skip updating for now. And then the suggestion, we're in Zigos. GDB, do we have GDB installed? We do have GDB installed. GDB into zigout bin kernel. Set architecture i386 x86 64. Undefined item. Interesting. Do I have a typo? Architecture. No, I do not. Oops. Okay, I guess just i386. Sure. Target remote 1234. What? Set architecture i386 x86-64. Oh, did I make a typo the first time? Oh, I did. I typed 84, not 64. Oh my goodness. My apologies. Target remote. Okay, cool. Remote debugging. Nice. Love to see it. Set a break on kernel main. Show me the QEMU. Okay. Just move this up to here for now. Continue. This is cool. I've never had to. Yeah, thanks for the 64, not 84. My apologies. This is really cool. I've used GDB and LLDB with Zig in the past, but I've never like connected to a different connected to QEMU or an emulator or another machine to actually do debugging. This is really neat. Okay, so we have a serial write on breakpoint 1 and stop when kernel main is hit. From there, next step, next one instruction. If the CPU crashes before hitting. Yeah, now the question, share what GDB shows when it catches the crash. Should we just continue again and see if we hit the crash? Maybe not. Let's hop back over here, run this bad boy again. Hey, that's makes me so happy that you are learning along with me. That is the whole point. I would much feel much more comfortable just doing this on my own, and but I feel like there's more value in doing it in a streaming case and letting other people follow along and hopefully have a good time. Hey guys, I have a question. Genuinely, how do I learn machine code? Like, isn't that an impossible thing? I don't. Um, why do you want to learn machine code? What is your definition of machine code, and why do you want to learn machine code? I don't think you probably need to go lower than assembly, to be honest. Anything else seems like you're just going to have a miserable time, unless you are really into like, yeah. Please clarify. Okay, remote debugging, remote debugging. Yeah, so where break kernel main. Let's try this again. Okay. We have 2 breakpoints there. That's fine. Let's go next. Cannot find the bounds of the current function. Step. Cannot find the bounds of the current function. Next instruction. Okay. Okay. Ones and zeros like pure machine code. I don't know why you would want to learn that. What value does that bring? And honestly, if you do want to learn that, I can't help you. I've not learned that. I don't necessarily have desire to learn how computers are processing specific ones and zeros. Uh, Give me my registers. Okay. Okay. I'm a little lost at this point. You could try break panic. I like that idea. Panic not found. Sure. Continue. Interesting. Uh, Knowing machine code helps you find every single memory leak and make system max efficient. I um I just don't. So I've been writing software for like 16 years and at varying different levels of the stack, and I have never needed to look at the actual machine code. Um I At least to the degree that you're referring to. There are other tools to help you find memory leaks, right? Like Zig has really nice allocators that will help you catch those. And at some point, you have to trust that like Zig is giving you tools that work, but it's a large open source library, and you can inspect the code to see that they do the things that they are expecting to do. Um, yeah, I don't know. I mean, I like the idea. I like the idea of pursuing something to learn something, but I'm not able to help you learn how to understand the ones and zeros that computers understand. Maybe someone else in chat does have some guidance on that, but I do not. Okay. All right, so let's try this again. So let's get in here. We're gonna set up a break on kernel main. I've set up like 4 freaking breakpoints on kernel main at this point. Continue. No? Try this again. Continue. Okay. Breakpoint, kernel main. All right. Looking at some more suggestions. Might need debug symbols from your build. That would make sense. I missed how you set up build, so I don't know what you're exporting symbol wise. I don't have hardly anything. Is that LX symbols, or am I misreading that? Is that LX might be Linux specific? Okay. Step through line by line. Okay. Why was this not working earlier? This is good, right? We're hitting our divide by 0 is indeed causing us to exit. No stack. Okay. Yeah, okay, okay. I think I can guide Claude at least in the right path here at this point. I used next to get to the line that caused the process to exit normally. This was the division by 0. My hunch is that we are exiting. Why are we exiting? Why do I have this hunch? We're exiting. What does our panic handler do? Just returns halt. Okay. Please look at the source code and advise. Lean kind of heavily on Claude here. Div by 0 is crashing. Why is there a divide by 0? This was actually a suggestion from Claude previously, just to test that our interrupt handlers are working like we would expect them to, which I don't think they are. So I think that's why we're running into this issue. But yeah, we do have this intentional divide by 0 here, to make sure. I'm not sure when you joined, Kristen, but the part that we're working on right now was the interrupt table. So yeah, we added our IDT, and the goal was to actually trigger an exception, and then handle it. But sorry, how did we miss this? Double fault, triple fault. That makes sense. Has to be populated before you load it. Lord have mercy. Okay. Let's hop out for a second. Yeah, ABI for our output. Okay, that makes sense. Set entry is never called. Source ID T. Oh, you're right. Did I miss that? Did I skip over this, or did it just give me like half of an answer? It did just give me half of an answer. There's set entry, but there's no reference to actually being called. Interesting. Okay, so why is this an issue? So IDT init loads the IDT register, but the table is all zeros. No stubs are registered. When the divide by zero fires, the CPU looks up vector zero, finds offset zero, selector zero, tries to jump to the address, which isn't mapped. Page fault, no handler, double fault, triple fault. The IDT has to be populated before you load it. That makes sense. LidT is the same LLVM inline assembly problem as LGDT. Okay, so it uses the inline lidT, which will fail. lidT load is already defined in IDT stubs. You just need to use it. Also notice the clobber syntax, memory true as the struct form that doesn't work. Same issue we hit before. I feel like I shouldn't need. If you want to lose all your skills, just vibe code. Yeah, I mean maybe. I don't know. It's so hard to tell, right? Like, not to make a weird comparison, but like it's kind of like GLP-1s. Like these are this new thing that everyone's swearing by, and it'll make you, lose a ton of weight and happy and all of this stuff, but like we won't know the long-term effects until a long amount of time has gone by. So yeah, I don't know. I don't necessarily mind using AI like this as more of like a digital assistant or digital researcher, maybe slash pairing partner. But just like yeeting code. I mean, I've tried it too. Don't get me wrong. Like literally, my most recent video was um, I vibe coded a little Windows desktop app to help with video editing for me, and it works good enough most of the time. But I also wouldn't like suggest vibe coding anything that people are paying for, or like, you know, um, using. Yeah, if you have like problems of load and production, and people are paying, like I think those are things that would make me really second guess vibe coding anything. But like the use case for the video editing app that I mentioned, like it's just on my computer. If it breaks, like the absolute worst thing that happens is I can't imagine it would be so bad that it bricks my computer, but it bricks just my computer. Um, but yeah. Okay, sorry, I got very sidetracked. Happy to see people chiming in and talking more though. Um, lid T is loaded. Didn't we already? Okay. Sorry, very long message. After this, when the divide by zero fires, the CPU should find a valid entry in the IDT, jump to stub zero, which pushes the fake error code in vector zero, jumps to ISR common. Yeah, actually, Kristen, if you don't mind, I would love to do that. Could I get your guidance on that process? I think that would be a wonderful learning experience. Set architecture I386 x86 64. Yay, it actually worked that time. I didn't mistype it. What was the other command? It was target remote. Okay, target remote 1234. Break kernel main. Sure. Continue. Oh, why did it just jump straight ahead? What in the world? Break kernel main, but that breakpoint doesn't seem to be firing. Kernel main. Oh my goodness. Did I did just run GDB directly. I need to actually run GDB with the table. Jeez, sorry. Let's try that again. Yay, that seems promising. All right, set up a, need to look up your notes. Monitor info registers QEMU monitor command. This shows IDTR with the base address and limit of the IDT. Okay, so let's set up a break on kernel main. And then we will monitor info registers. Okay. And then what we should probably do now is I'm going to split back to that source code view, layout source, continue, hit our breakpoint, go next, go next, go next, go next, go next, go next. And then now we want to monitor info registers. Yeah, those are all zeroed out. Okay, cool. That's our issue for sure. Jivish. Hello, sir. Love from the United States as well to you. Thank you for representing India. Okay, cool. So that does seem to be our issue. Yeah, it makes sense that we would need to actually set these entries. I'm so curious. Yeah, quit, please. Yeah, that's fine. I'm so curious why Claude just omitted all of that. And also, how do I bring myself to handle this? So we have our IDTR. Do we have... No, okay. Oh man, I don't want to copy and paste, but I also don't want to just type the same thing over and over again. So calling convention C. Okay, let's try it. Get all of our 32 stubs, and then we will throw those right in front of our init. And then down here, we should call set entry on all of those stubs. Just double checking something. So we have our IDTR. I was kind of expecting those to need to be... Oh, okay. Okay, that makes sense. That makes sense. All right, let's... Yeah, literally there's a comment for it and everything, but it was just never added. All right, let's give it another go with this. So let's start with build ISO. Nice. Oh, yeah. Shoot, what was the... I'm trying to remember how we solved this previously. Pretty sure it was naked. They all need to be updated too. Let's just search grep call conv. Did we need calling conventions for anything else? No. Okay, let's just try to remove the calling conventions for now and see if that helps. Very exploratory. The amount of zig to C I've done has been fairly small in the grand scheme of things. I should also probably just percent colon call conv. Oh Lord. Just vim find replace. S, yeah, that's right. Right? Pattern replacement. There we go. Sorry. I've been using a different editor for too long. Did that not remove it? Oh my goodness. Good enough. There we go. Okay, cool. We have our ISO. Let's give it another run. Set architecture, architect, CHITECTURE, I386, X86, 64, set remote, set target remote, 1, 2, 3, 4. Oh man, I've already forgotten it. Just target remote. That makes more sense. Target remote, 1, 2, 3, 4. Break kernel main. Continue. Layout source. Continue. Oh, continue is not what I wanted. Hey, that's a good sign though. That it hasn't crashed, right? Nice. Okay, cool. We have our interrupt signal. Excellent. Okay, cool. Cool. There was a fantastic question in chat from Kristen, which is, can you use zig comp time to stub all? Yes, totally can. Probably should. That would probably be way nicer. So I don't know if I'm going to do that right now, but I am going to leave a comment and suggest that I go back and do that. To do this should be comp time if possible. To do this should also be comp time if possible. Yeah, a lot of duplication there. I feel like we could definitely make that better with comp time. Okay, cool. So serial output ABI. Yeah, spot on. That's exactly what has happened. I just realized my mouse cursor has been setting over the chat this whole time. Let's see, we've been live for an hour. Okay, cool. Oh yeah, we should probably remove that divide by 0. That's a really good suggestion. Let's do that. So let's remove the divide by 0, and then let's just make sure we get further along. I'd like to get to at least the D serial write. So let's get there. So let's give this a build. Let's give this a QEMU. Yeah, sure. We'll throw up the GDB one more time. Set architecture I386 x86 64. Target remote 1234. Break kernel main. Continue. Go go go. Layout source. Next. Next. Keep going. Nice. Made it to C, made it to D, made it to our assembly where we halt. Awesome. I will take it. Okay. ABC, ABI, CD. Okay, cool, cool, cool. That sounds good. Let's go ahead and commit. That's a really good idea. So commit IDT table with some to-dos. I'm at a fork. Okay, cool. So before moving on, clean up and commit, remove the divide by 0, uncomment the VGA right. Oh, sure. Let's do this too. Let's do this too. Source, main. So we can remove this. No, this. Give it another build. Let's see if this works. I have to imagine it won't, but that's okay. Oops. Let's skip these two for now. Actually, sure, one more time. Target remote 1234. Page fault. Okay, cool. Yeah, we are getting a page fault there. Instead of a halt, you might need an infinite loop at the end to see text. That would make sense. I think our issue at this point is we are trying to access memory that has not been provided from Limini, however it's pronounced. We need that frame buffer. But yeah. You can interact with your OS or a physical memory manager first. Oh. Do you have any suggestions, chat? My hunch is we probably go with B, since everything's going to need to build onto it. Yeah, maybe we do that. Maybe push the pointer to the stack onto the heap and use pointer to pointer. And map has my vote. Yeah. Okay. Let's start on mmap. Let's plan out option B. Actually, let's do option B. It knows not to write any code for me. Hopefully it won't forget. Okay, cool. So add back in broken VGA buffer writing. Note, this causes an exception to fire. Long commit message, but it'll be all right. Okay. I'm also, while Claude is churning, I'm going to swap music to Bill Murray, please. All right. Yes, that's fun. All right, Kristen, you've been super chatty and super helpful. So I'm gonna, while this is churning, while it's frosting, I guess, I will ask you some questions if you don't mind. I'm curious, do you work on low-level programming or operating system stuff outside of helping struggling YouTubers figure it out? For fun, yes. You work at Credit Karma on the backend frameworks team. I happen to use Credit Karma, I'll have you know. Um, so I have to imagine your backend framework helps make my day a little better. Yeah. I was going to show you my Credit Karma, but I feel like that is doxing myself way more than I would want to do. That's cool. I really love that you do that for fun and then also work on backend stuff at Credit Karma. Okay. No header file ships with the package. I'll provide the magic numbers from the protocol spec, but more on that in a moment. First, your note about replacing this later is a good instinct. The right approach is to keep all this specific structures isolated into a single file. When we eventually write our own bootloader, we'll only touch that one file. Everything else, PMM, GDT, IDT stays the same. That's the design we'll use. I love that. That sounds like a really good plan, Claude. Concepts first. What is physical memory? RAM is a flat array of bytes. The CPU and OS manage it in chunks, 4KB, called page frames. We're finally getting into an area that I have a level of comfort in. So I've not written a memory mapper before, but at least, we're at a high enough level that I'm familiar with how all this stuff works. The physical memory manager's one job is answering two questions. Give me a free frame, and this frame is free again. This isn't a question. Is this frame free again? The memory map. We don't own all of RAM. Some of it's reserved by firmware. Some holds ACPI tables. Some holds the kernel itself. This gives us a memory map, a list of regions with types. Usable is 0, reserved is hands off, 5 is bootloader reclaimable. So it's its own structure, safe to reclaim later. I'm curious if this is safe for us to reclaim. I have to assume yes, right? Because after this has booted and has done its bootloadery type things, it probably doesn't need any of that anymore. Kernel and modules, our code lives here, and then our frame buffer. We only hand out frames from type 0, usable regions. The kernel itself is already marked type 6 by Limine, so we won't accidentally give it away. The bitmap allocator, we track free use frames with a bitmap, 1 bit per frame. These are pictures. Okay, so this makes sense. 1 bit per frame. Bit 0 means free. Bit 1 means used. For 4 gigabytes of RAM, 1 million 48,576 frames. 128 KB for the entire bitmap. Okay. Yeah, that is tiny. Oh man, Kristen, you're in the right place. I used to listen to a lot of Bring Me the Horizon. Man, I struggle to type and talk at the same time. But I'm old, so I listen to old Bring Me the Horizon. It's a doomed Mafra cover. Specifically the Mafra vocal cover. Okay, I might have to YouTube that. I will try to remember. Let me just make a note in my phone. Bring Me the Horizon. Mafra cover doomed. You got it. I'm going to a music festival that is a metal festival, and to be completely honest, I've not listened to much metal since like 15 years ago at this point. But a couple of bands that I want to see are going to be there, like My Chemical Romance and Iron Maiden, and a couple others. But at the time I bought my tickets, those were the two that were announced. And I've decided that I'm going to start listening to everything on the festival lineup, so I have an idea of what I'm getting into. And I mean, I listen to some metal, but um, I started with Bill Murray, and I've basically only been listening to Bill Murray. So country metal pop is like, it's such a strange mix, but it works so well. Okay, so this file holds all of the protocol structures. Yeah, let's do this. So let's start here. Yes, sure. Protocol structures isolated here, so replacing limine later only requires changing this file. Hopefully, let's be honest about that. Pub const mem map entry type. So we have our enum. So we have a U64 for the enum type. Reserved. ACPI reclaimable. ACPI NVS. Bad memory. Bootloader reclaimable. Oh, that's not right. 5. Kernel and modules 6. Frame buffer 7. Catch all known types. Const mem map entry. So we have an external struct. Base is going to be a U64. Our length U64. Type mem map entry type. Makes sense? What else we got? Mem map response. Quite a bit. Extern struct. Revision U64. Entry count. My grand ambition for this project is get it working. And then my second grand ambition is take everything I've learned and port the code to both Odin and Rust and figure out which I enjoy more. Happiness is the grand ambition. Request. It's an external struct. ID for U64 revision e64 response is going to be an optional pointer to a memmap response. Let's fix that typo, add our semicolon. Okay. I guess I didn't need to do that. We could have just hopped over to main.zig, but here we are. Next to your existing limine base revision, add. Yeah, okay, that makes sense. Excuse me. Import limine.zig. Oh, I did not expect to run into this. I have a Zig question here. Oh no, wait, never mind, never mind. Link section. Okay, so we have our ID. I will copy magic numbers. I'm not above that. Maybe. Okay, what else we have? Revision is equal to 0. Response equals null. Sounds good. Then in kernel main, after idt init, so we can head to idt.init. I know that's a pattern that is kind of common in Zig, but man, I do not like it. The importing things like directly before you need them. I'd rather just have them at the top of the file. Might be worth knowing the mmap spread in those numbers. I'm going to get that started. It's going to have to compact the conversation, but hopefully we can get more information there. Unfortunately, it doesn't tell us much in line. I'm glad you reminded me, though. The whole point is to learn, and if these are magic numbers that do serve some purpose other than just being like, for example, like SQLite has some magic numbers at the top that are just like specific one-off magic numbers to indicate that it is a SQLite file. But like this, right? Like the common magic shared by all. Like if that is just what it is, that's fine. That's a really good point. These are yeah, I probably should figure out what these are. Hey man, followed along with your Zig Invader series a few weeks ago. Thank you. That was great. Man, I'm really glad you enjoyed it. It was a really fun thing to build. I do feel a little silly after the fact of building it in Zig and not doing any allocations, like not doing any heap-based allocations, because I feel like allocators are a big part of Zig. And I did not make a single allocation in the video. So I felt like making it a bonus lesson that talks about allocations and allocators and things of that nature, but I honestly just have not gotten around to it yet. But yeah, if you enjoyed the game dev side and you have any interest in Odin, there's also a 3-hour long building a 2D platformer in Odin type video that I've done. Shameless plug. This is what you build. So you get this and 3 levels, level complete screen, some stuff like that, victory screen at the end. But yeah, it's all written in Odin using Raylib, and yeah, this one was Raylib. The SDL was a different one. Um, but yeah, learn all of this in 3 hours too, and it's not sped up and it's not like aggressively chopped up or anything. It's just Odin is a fantastic, simple language for building stuff like this. So if you enjoy the game dev side and want to do more on that front, you could always check that out if you're interested. But I'll stop plugging my own stuff and instead hop back over to what we're doing today. Thank you for letting me know you enjoyed the series, though. It does help me know where I should spend my time. Okay, so magic numbers. We'll get to those in just a minute. Then in kernel main, after the IDT .init, serial M for mmap missing, checking the response. After the init, okay, so we have our serial write for I. Let's do const memmap is equal to memmap request response or else. So if it's empty, we'll indicate that we have a missing by writing M. Sure, M is equal to memmap missing. While true, ASM volatile halt. pmm.init. And then we want to pass in our memmap. Serial write, big P. We haven't. Okay, I was like, this doesn't exist yet, right? Am I crazy? Okay. Save that. Source pmm.zig. Yeah, sure. Start by importing limine. Import limine zig. Page size is equal to, it'll be U64, set that equal to 4096. 1 bit per 4 kilobyte frame, supports up to 4 GB of RAM. Sure. Stored in BSS, no cost in the binary. 0 initialized. That's not good. Oh no. I was in the middle of implementing what you had just suggested, and you've compacted the conversation. So I no longer have access to your guidance. Well, at least we can learn about these magic numbers while we figured that out. So these are hard-coded in the spec, so the 8.8 and the 7B. Every single request type, memory map, frame buffer, HHDM, SMP, whatever, starts with these exact two U64s. The bootloader scans every writable load segment in your ELF looking for this 16-byte pattern. LLM tip, always get it to write to MD files. Yeah, that makes way more sense. Oh man, I thought we were really in a bad spot there. Maybe we are. We'll find out. But limiting bootloader scans every writable load segment in your ELF. I'm looking at a limine request struct. Request specific magic unique per feature. So the 6F and the 6.2, these two U64s tell it which request it found. The memory map request has one pair, the frame buffer request has a different pair, the HHDM request has another, etc. Think of it like a type tag. Okay, cool. The full scan flow iterates through your ELF's writable load segments byte by byte, finds common magic indicating that this is a request, reads the next two U64s. So this is a memory map request specifically, fills in response pointer with the actual memory map data, continues scanning for more requests. Okay. Okay, that makes sense. I feel like this is maybe a sign that removing Lemine later is going to be a bit more of a pain than I expected, but that's all right. It is what it is. Y4 value is not just one. The common magic prefix lets Lemine ignore anything that accidentally contains one of the specific request IDs, a random pointer, or integer, and your kernel data could theoretically match a single 8-byte pattern. Matching 16 consecutive bytes of specific magic makes false positives essentially impossible. Then the second pair narrows it down to an exact feature. Why is the base revision different? Only 3, no common magic. It's not a feature request, it's a protocol handshake. Looks for it by different mechanism. Okay, cool. It makes sense. Okay, cool. Let's fix this too. So I feel like it threw away a ton of our comments, but we'll deal with that. Const max frames U64, so 1024 times 1024 covers 4 GB of physical memory. Each bit represents one 4KB page frame. 1 is used, 0 is free. Okay, fair enough. Var bitmap, what else we got? Max frames divided by 64. U64. Okay. This is interesting. So each bitmap represents one 4 kilobyte page frame. 1 is used, 0 is free. Okay. Just initializing that. Oh man, it's too early to be sleepy. Consider taking the 64 and making it a var. That way you can change it later for more mem. Sure. Free frames. U64, set that to 0. Okay, set bit frame U64 void U6 truncate frame modulus 64 bitmap frame 64. Ooh, wrong thing. Comp time cast to a U64 1 bit shift by the shift. Okay. Yeah, yep, good catch, good catch. Clear bit is going to be similar. U64, we have a void return type. Our shift, U6, truncate, frame modulus mem size. Bitmap frame, yeah, mem size. I'll go up and fix the other one in just a second. U64 for the type. Okay. Let's hop back up here and get this one too. Thank you for the suggestions. Memmap. Response, void. Start with everything marked used, all bits set. Beautiful memset call here. Let's go zig. Find the highest physical address to compute total frames. Var highest is going to be a U64. Yeah, holy cow, I'm getting sleepy. And it's only 5 o'clock for me, so no excuse. Entry count, bind that to I, const entry. We'll get the memmap entries, I. Let's see what else we got down here. Okay. So memmap entries, I. The end will be the entry base plus entry length. If the end is greater than highest, then they swap. I feel like we're solving leak codes again. Total frames, highest plus page size plus, no, -1. Mark only usable regions as free. Okay, for 0.memmap.entry count, I const entry equals memmap.entries. If the entry type is usable, start frame entry.base divided by page size, const num frames entry.length divided by page size. For 0 num frames, f clear bit, okay, start frame plus f, free frames. We're gonna have a fun prompt after this. Pub fun alloc optional U64. All right. For 0 to total frames, hey man, I don't mean to be critical of you. It's a cool stream and an interesting topic, but I noticed you're just typing down the Claude generated code by hand. May I suggest you forbid Claude from generating any code for you? Just have it tell you what must be implemented, not how. This way it'll be a true learning experience. Yeah, I appreciate it. This has worked out okay for me, but this is sort of a double experiment. Part of it is seeing if the two things. I don't know how to build an operating system. I have no idea. And that's the first part of this experiment. Can I figure out how to do that with some assistive tooling? The second part of the experiment is, do I learn anything from using the tools in such a way? I definitely get what you're saying, and I actually I think you're probably right that I would probably move slower, but have a better learning experience if I were saying, "Hey, don't do any of the actual coding for me, and instead just kind of guide me on the approach." I think you're probably right that I would have a better learning experience that way. Um, Yeah, I don't know. I think you're probably right. I am going to continue with what I have going for now, I think, but I don't know. We might change it up too. My thought process is that these tools are really interesting, and the main premise that I see that I have the biggest struggle with is people who prompt and um, don't actually like write anything by hand, don't learn anything, and even if like for the longest time when people um, would many years ago, going back to how old I am, people would talk about copying and pasting code from Stack Overflow. And even in that scenario, I was a big proponent of like, don't copy and paste from Stack Overflow. Even if you're going to use exactly what they have, type it out by hand. And I guess I just have this weird belief that like the amount of time and the amount of attention required in reading and typing will force you to learn something whether you like it or not. I do think that maybe having a higher level solution for each problem kind of posited towards me, and then letting me break that higher level solution down into lower level code actually probably would be a better learning experience. And yeah, I don't think you're being critical of me at all. I appreciate the feedback. My goals, like, I mean, I do this for multiple reasons, like the YouTube stuff for multiple reasons, but really, like, the reason I'm doing this project is to learn. So if you have suggestions on how to learn better, I'm like, like that sounds like $1 million advice right there. So I'd be happy to hear it anytime. Yeah, finger osmosis. Yeah, I think it's more of just like there's like these four different types of four styles of learning. These really nice tiny picture. Let's see what else we got. Maybe a site that doesn't have them so tiny. Uh Big image, big image. Yeah, yeah, this works. Okay, so despite this looking like something you'd find in a preschool, I do think this is still pretty valid. So there's visual learners, auditory learners, read write learners, and kinesthetic learners. Um, Worth mentioning, I personally feel like vibe coding fits none of these, and I think that that is also a sign that like maybe people who are vibe coding aren't doing it to learn. Um, I fall into this category pretty hard. So for me, this works pretty well, even though I'm having the problems essentially kind of solved for me. Would I be learning differently if it was higher level? Yeah, probably. And maybe that would be a better approach at some point too. But yeah, I don't know. Those are my thoughts. I'm still figuring all this stuff out. So again, I definitely like you're not being critical, and I appreciate the input as I'm trying to figure out my own feelings on these things. Spec-driven development with LLMs and ADRs. Yeah, I do. I feel like I don't know. Spec-driven development's interesting. I don't. If you're gonna vibe code, I think that's probably the way to do it. I guess I just like I've built software as a service systems that I am on call for, and I get nervous about the idea of like vibe coding something and pushing a change to production without like truly understanding it. And like if you read your code you understand it, right? But I don't feel like I have the same level of understanding if I wrote it by hand and like ran the code by hand as I was running through it, and would brush up against the problems with the implementation and learn the parts where it falls over, and the trade-offs that have been made, because a lot of times LM will make trade-offs for you, which actually we're seeing all the time here. Like, it is making decisions on my behalf when there are opportunities for me to make those decisions, and it's not even asking me. It picks a path and follows it. So yeah, no, again, not being critical of me at all. I appreciate your insights. um yeah. IDX, we'll try that for the next one. We'll see. What I will do is I'll prompt it very precisely because I had given it a requirement that it can't actually write to any of my files for me. I'm not sure if it'll still follow that after the compaction of its context, but yeah. So I gave it that ask originally. So I'll just swap it around on the next one, and we'll see during the next segment if we have. Yeah, we should have time for more during the next segment if it will um, be cool with not giving me code and just kind of like outlining the tasks. And then I'll ask it to probably code review the implementation. You know what? I think I like that a lot. Oh, that's a lot of Fs. Oops. My God, what am I doing? Okay. I had success doing this with envelope encryption, key cache with specs and ADRs plus an sorry, is that plus or minus? Minus an adversarial test suite. Note that it costs 2K. Yeah. Yeah. I don't like I don't know if I have much to add. I'm glad that you've had success with it. Um that cost is pretty like so noting that it costs 2K, was that like 2K for the adversarial test suite, or was that 2K for the like the entire thing, like prompting your way through with LLMs and ADRs? Um yeah, I'd be curious to learn more, I guess. I do worry that to an extent certain things in tech have become pay to win due to LLMs. Return frame times page size. 2K was for the spec requirements, multi-pass review with team of agents. Interesting. Hey, and that's a lot of money. Oh, we need a free method, and then we'll be good to go. Pub fund free ADDR for address, U64, void, clear bit, ADDR, divided by page size. Free frames plus equal 1. Sure. Okay, the memset bitmap line needs a note. Memset with a U64-bit array, which correctly fills every U64 word with all the bits set, all frames used. That's intentional. We start pessimistically and only free what limiting confirms is usable. Once you paste it in, run zig build, and if it compiles cleanly, test. You should say ABIP to ensure that PMM init returns successfully. Good start so far. Build ISO QEMU. Target remote 1 2 3 4. Yeah, that's fine. Continue. Oops. Definitely pay to win. Table stakes or pay to play. Yeah, yeah, that's interesting. So let me see this either crash or do what it's supposed to do here. Okay, cool. We got to the P. which is good. We all like to see that. Yeah, I guess we can terminate it here. Okay. Yep, that worked. What's next? Don't give me code examples directly. Just help break down the work into small chunks and I'll code it myself. Let's give it a shot. Um, yeah, I feel like a lot of small software as a services are just it's pay to win at this point. If they even will exist much longer. Um, I do think that it's I don't know. As someone who's been building like a software as a service type thing for 5-ish months now, I don't know. I had a blog post like shortly after we published the first. Worth mentioning, this is not available for use yet, um, but I've already started blogging on there. So holy shit. I mean, sorry. Holy carp. Please don't demonetize me. I did not realize that this was so far back. Yeah, we had so many come out on August 16th of 2025. It's me. This is something I've been building, but it's essentially just a tool to kind of put the humans back into the business side of things. So focusing on like connecting people with one-on-ones, OKRs, individual development plans, and peer feedback. These were all things that have been really useful in my career. And I've also, as someone who's managed as well, seen people not take advantage of these things. And like specifically making your one-on-ones more than a status update, I feel is so important for your career. But again, have seen so many people just not make good use of those. So just trying to find ways to make sure that one-on-ones happen and they're actually useful and things of that nature. So I'm building something, but also a little nervous now with LLMs just like you said, kind of making things pay to win. Also of note on the EE, one spec was approved by staff eng. The code took 30 minutes to generate and had very little pushback from reviewers. That's neat. What language, if you don't mind me asking? Rust. Okay. That's interesting too, because I feel like Rust is a language that has you have the opportunity to like pick a path with Rust, right? Where like Go, there's generally one way to solve something, but with Rust, like you could take I have to imagine quite a few different approaches between traits, just having functions that operate on types directly. Like I don't know, I guess it's kind of interesting. Migration from a Scala base. Yeah. I used to love Scala and I have not written much since Scala 3 came out. And to be honest, I feel like Scala's population has been the population of Scala developers, that sounds like they're dying. The amount of people who are writing Scala has decreased as time has gone on by quite a bit. That's just a hunch. I don't have any like scientific proof, but yeah. You have a working kernel that can boot, handle CPU exceptions, and track physical memory. The natural progression here is virtual memory and paging. Scala's dead. Long live Scala. Yeah. I loved Akka. So Scala, Akka, for anyone who's not aware, it's an actor framework. Um, why? Why is Akka agentic AI? Uh, wait, this is not the same thing. No, it is the same thing. What? When did this change? Yeah, actors. That's great. What is all this AI stuff? What are they talking? Akka Classic. Take me home. What in the world? Okay. Yeah, cool, cool. I'm getting old and I don't like it. We killed off Akka 6 months ago. We as in the Scala community, or we as in your place of employment, which I realize I probably shouldn't dox you by saying publicly on stream. Pecco, what is Pecco? Okay, yeah. Pecco is an open source framework for building applications that are concurrent. Yeah, this sounds like Akka. Cool. Fork of Akka 2.6. Yep. Okay. Oh, they went BSL too. Man. All right. Cool. Let's get back to something slightly less painful. Okay. So right now, Limine has set up a temporary page table that identity maps low memory and maps your kernel to the higher half. The mapping is limines. You don't own it, you don't control it, and it'll become a problem the moment you want to allocate memory for new processes, do anything in user space, or implement a heap. Establishing your own page tables is the foundation everything else builds on. So before writing any new code, use QEMU and GDB to inspect what Limine has set up. Read CR3, walk the PML for this is pure exploration, no code changes, just building intuition for the data structure you're about to own. 7B would be defining those as pack structs. So get the bit fields right, present writable user, write through, cache disabled, access dirty, huge page, global NX, and the physical address bits. Write a VMM zig that can create a new address space. Switch to your own page tables. Yeah, let's do this. Yes. Okay. This doesn't need to be as big as it is, I guess. Well, all right. I guess it'll stay. Okay, so boot with the GDB stub attached. Launch QEMU with these extra flags. Yep. Okay. We're connected. Want to instate the spec after Limine has handed off to your kernel, so the page tables are fully set up. Set a breakpoint on kernel main and continue to it. So the page tables Limine built are live. To see them, read the C3 register. Man, I just don't know GDB well enough. Is it just a read command? Info registers. Print. Okay. Oh, okay, cool. That actually might work. I've already forgotten. Man, my memory's so freaking bad. Holy cow. Print. Okay. And it's CR3, print CR3. Does it need print CR3? Yeah, it does. Holds the physical address of the top level PML4 table. Info registers CR3. Sure. Okay. The PML4 is an array of 512 U64 entries of that physical address. In Lemming's identity map, physical address equals virtual address for low memory, so you can read it directly. Examine 8 bytes at that address. Okay. X 512GX, and then the value from CR3, which has to be this, right? 3BD 9000. Oh, is it actually the... Oh man, X 512GX. Okay. CR3. Thank you. Again, a little out of my comfort zone. Oh, okay, but it is the same value, but it says it cannot access. Interesting. Just out of curiosity, if we go next and then try. Yeah, interesting. Cannot access the memory. Huh. Okay. Most entries will be zero. Look for the non-zero ones. Those are active mappings. A non-zero PML4 entry encodes a physical address into bits, 51 and 12. Mask off the low 12 bits to get the address of the next level. Okay. And keep going and keep walking down the same way. At the PT level, each entry's masked address is a physical page frame. What to look for? Find the entry that maps your kernel's higher half address. So this one in the PML4, that virtual address lives at index 511, the top entry. Trace that chain all the way down and verify it points to your kernel's physical load address. What do I see in CR3 whenever I run it? Sure. So CR3 is giving me 0x3BD 9000. However, X512GXCR3 gives me a cannot access memory at address 0x3BD 9000. Is the X512GX correct? To be completely honest, I don't know. I'm trusting Claude on this one. This is a little beyond where I'm at with my GDB debugging. Oh my goodness. MCP, the GDB. Lemmian maps all physical memory at a fixed virtual offset called the higher half direct map HHDM on most Lemmian setups. This is okay. So the physical address would be accessible at virtual address. Okay, so if this gives me readable data, you found the PML4 and can begin walking down from there. Let's give it a shot. Hey, okay, cool. All zeros. Oops, all zeros. What are my options for layout? Okay, that is not what I was wanting. Okay. Cool. So we're able to get that. Okay. What are we looking for? So we have one here. So we can grab. Okay. Okay. I think, some of the value of this, but I'm not 100% sure what value that necessarily is providing at the moment outside of exploring the memory layout in GDB. I guess I probably should have followed that all the way through. No, I did not. Oh, Lord. Okay. If you insist, Claude. Set architecture I386 x86 64. Target remote 1234. Yep. Okay, cool. So X512, this giant value. GX. Okay, there's a page. So there's a value at OXO. Oh my God, that's so many O's. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3BC 0027. Oh, there actually is an MCP for GDB. That's wild. Okay, the low 12 bits are flags. This is actually helpful. I'm kind of glad that Claude pushed me back on this and was like, "Hey, we should do this." That's a PML4 entry. Let's decode it. So the low 12 bits are flags. So the OX27 in binary is 00100111, which means the bit is present, it's writable, it's user, and it's accessed. Okay, I see now why this is important and why Claude is pushing back. To get the physical address of the next level, PDPT, mask off the 12 lower bits. Oh, and we have to add the offset. Okay, that makes sense. So X512, GX, 0X, FF 80000 3BC Same thing. Oh, what index was it at? I don't know what index it was at. Jeez. I ran this. Do we have copy and paste support? We do. Feed it screenshots. I actually don't know how to do that. Can you just do that with the TUI? So the GDB is showing you 2 entries per line. Index 0 has a value. Index 1 is 0. Yep, that makes sense. Okay, so these are both associated with the same value here. The non-zero entry is same flag pattern as before. Present, writable user access, strip the lower 12 bits. That's a physical address. The next level down, a page directory, read it the same way. You're now 3 levels deep. You have 1 to go before you hit the actual page frames. You got it. Also, when you look at the full output from each X512GX command, note which indices have non-zero values. The index tells you which virtual address range that entry covers. Most of the 512 slots will be 0. The non-zero ones are the active mappings. Okay. Take a screenshot into the clipboard and you can just paste it into Claude. Really? I had no idea. I think, sorry, 1 second. Yeah, okay, let me close this. I just heard sounds from the Android emulator that I had running, and I was like, "What in the world? Where did that come from?" Okay, cool. So we have a lot of non-zero values at this point. No page table below it. Mask address directly is a 2 megabyte physical page frame. So to code the second entry, that's a physical address of 2 megabytes mapped as a 2 megabytes each page. Okay. GDB. Just save that for later. So decode it. Okay, 2 megabytes mapped as a huge page. The pattern continues. This maps 4 megabytes. Also, you don't know Claude has a voice mode too. I did not know that either. Do you just is that like whisper sync where you just talk to it and it? Yeah, very curious about that. You seem like you are far more up on the Claude than I am. Point to page tables for finer grained 4 kilobytes mapping. That's probably where kernel's actual code data pages live since they need specific permissions. Voice and spacebar to talk to it. Um, I'll try that at some point. I will skip that for now, but yeah, I'm definitely down to give that a shot. Yes, let's do it. Let's go all the way, Claude. Take the first entry, mask off the 12 low bits. Okay. Okay. The mask addresses of each entry is the physical address of the actual frame. Okay, cool. This is starting to make more sense to me. Here's the first 2 lines. I thought they took Ultra Think away, where it always does that like same level of deep thinking now, but I could be wrong on that. I remember seeing something months ago where someone said that if you typed Ultra Think, Claude would prompt you that it's not Ultra Thinking. It like that doesn't do anything anymore. Oh, it's back. Okay, cool. I know they added effort as well, so you can set the effort level, but I don't entirely know what that entails. Flags OX3 bits. Okay, present writable, no huge page bit. You're already at the bottom level. Okay. This is like this pattern of managing this memory mapping is actually really wild. I do think I probably want to spend some time thinking about this more than anything. It's like I'm starting to see the patterns here. So like this is actually pretty straightforward in the first column, and the next column is pretty straightforward as well. Especially since they're just 4 kilobyte pages. This is starting to make more sense with the mappings. But getting down to this point from the previous ones, it's actually like really interesting. Yeah, each level is an array of 512 U64s. Non-zero means mapped. Mask off the low 12 bits to get the next level's address. That's so interesting. And I guess, like in theory, this could just keep going too, right? I mean, there's a ceiling at some point, but yeah. Paging structures. How far into the stream are we? We're 2.5 hours in. It's 6 o'clock. Oh, do we continue, or should I go get dinner? I'm uncertain as to which I feel. Go rest. No sense going on if you're tired. Yeah, you're probably right. Let me contradict myself by looking at the current viewers number. Okay, yeah, not high enough that I feel bad abandoning the stream. So yeah, you're probably right. I will do that. I will go take my break and go get some food. Um, really appreciate your help, and really appreciate the time chatting with everyone as well. So we'll pick up here next time, probably next week. I don't know. We'll see. Yeah, tomorrow's Easter, so yeah, probably not tomorrow. But I will aim to probably do this next weekend, and then I'm sure I'll put out some videos, something this week too, as well. Probably either talking about using level design toolkit with Odin or the Dust media server project that I've been working on. So yeah, keep an eye out, I guess, if you care for that type of stuff. And yeah, thank you so much for your time and hanging out. Um, have a great day.